Hi everyone, we're Team 2 of the UAS SAR program at BWSI, and this is our final presentation. I'm Emily, and I'm in the top right corner.
I'm Nithish, and I'm in the top left corner.
I'm Constantine or Nino in the bottom left corner.
I'm Tianjio or TJ in the bottom right corner.
So, SAR, or Synthetic Aperture Radar, provides 24/7, 365-day all-weather imaging of the surface of the Earth, allowing us to quantify and qualify regions of interest, said very well by our wonderful instructor, Ramu. And basically, the radar is sending and receiving pulses and forming an image with the data that it received. And here's some cool examples. And for the table of contents, first we're going to talk about radar command and control, then back projection. We're going to do a live demo and then talk about our lessons learned.
Explain radar command and control. So for radar command and control, it's basically just the communication between the host and radar. It processes the inputs and outputs, telling the radar, scanning how many times, scanning for how long, what movement it goes when collecting its scans, and what's the range of its scans. And it eventually receives all of the scan data returned by the radar to go into the back projection and eventually process into a star image. So the graph right here on the right is a general outline of the commands between the host and the radar. The radar in this case would be an emulator, an online simulation of the real-time radar, since due to the pandemic we cannot have access to a real radar. And the host would just be our code commanding what the radar does. So in certain cases, we just tells the radar, gives the radar the configurations of how it should scan and how long it should scan, all that information. And eventually the radar will start scanning and giving back us, the host, all the scan infos as seen right here. So this is basically a example of how the radar and the host would interact. On the left is our host and the code get output by our host, and on the right is the outputs of the radar.
All right, hey everyone, I'm Nithish, and I'll explain to you everything about back projection. So SAR imaging as a whole is divided into two parts: signal processing and image formation. Signal processing contains of two steps called pulse compression and Doppler effect. And these two steps as a whole in SAR involves ordering scans and processing the values, usually amplitude and phase. And the radar usually takes care of the first part, but processing these values is something that we have to implement. And in image formation, we use interpolation to form our image. This not only makes our program faster, it also smooths the image out evenly. Interpolation, how interpolation works is that it assumes the values in between neighboring data points, and these values are layered on top of one another to make an image of reflectivity. And we use this by NumPy vectorization, which we had to research a lot on. And the integrals involved in these are not fun, as you can see in the big equation in the right. And these two steps as a whole make up the basics of back projection.
Hello, I'm just gonna show you all the demo. Normally this demo would include our command and control code, but in the interest of time, we've kind of just cropped that bit out because, let's be honest, waiting for the emulator to boot up in the real mode is very difficult. So we're just gonna show the back projection part because that part's really fast. So here I am just gonna run this in the terminal. We can choose an arbitrary length and width, but in this case, I'm going to do something that is 5x4. Center, it's relevant to a coordinate plane. We know where the radar is flying, so here it's just 0, 0. The pixel resolution is just how many pixels per meter. And this generates really quickly. So the connection between our our command and control and our back projection are connected mainly by the radar's command and control getting the data back from the radar and then just processing it into a certain format, and then in that format it gets passed to back projection, and basically, you get to do whatever you want with it, really. So the image is formed now. And that is this. This is our image. This is a color bar for reference. But if you don't know what this is Vincent van Gogh's Starry Night.
Hi, I'm Emily, and I'm going to talk about the lessons we learned. So our main takeaway was that respect, care, and trust for each other makes a team. We basically lived by this, and it made working in a team really fun and also productive. We also learned to play to each other's strengths and make sure that everyone was always understanding what was going on, even if it meant we had to project a whiteboard and figure some stuff out together. And we also learned a lot about problem solving with coding through this program. We learned that we should isolate problems using print statements, and also that optimizing our code through interpolation, like Nithish talked about, was super, super helpful because it meant we could run our code so much faster and find those problems easier. And we also really learned how to ask for help, like how and when was a good time to ask for help, which is a skill that a lot of us didn't really need that much before, but this is such a complicated program that we knew when to ask help from our instructors. Thanks, everyone. We had a lot of fun with this program, and we'd like to thank the instructors and TAs for making it so much fun, and we learned a lot.